Hello Assalamualaikum, my name is IKMAL and I will explain to you the code by highlighting the code itself. Alright, so for the first one, this line ensures Seaborn is installed. In Google Colab, it's usually pre-installed, but this guarantees it is available without errors. For the next one, the imports one, here we import our core libraries, pandas for data and manipulation, numpy for numerical operations, Seaborn and matplotlib.pyplot for data visualization. Then, now we bring in tools from sklearn for machine learning. We will use them later for splitting data, scaling features, training an SVM model, and evaluating prediction. Here we are loading the Titanic dataset using Seaborn's built-in function. It is a classic dataset for classification. The goal is to predict survive column based on passenger info. This displays the top 5 rows of the dataset so we can preview the columns, data types, and contents. It includes columns like sex, age, fare, and bucket, class, and more. Okay, thank you so much. That's all from me, and I will pass to my friend.
Hello, my name is IZZAT AZIZ, and I'm gonna present about the import libraries. So basically, import libraries work with data, visualize data, build and test prediction. This all import pandas, import numpy. So we go to the next one. Load Titanic dataset from Seaborn. So basically this is basically it load dataset using Seaborn, and it contains details like name and age. We go to the next one. Clean the data, which is this one. Drop irrelevant columns, which means you remove columns that we don't want. And then we go to the next one. Convert categorical columns to numeric. What does this mean? We change words into numbers because computer read perfectly understand numbers than alphabet. And then we go to split features and target, which is this features and target. What does this thing do is that things that we know, age, and sex, gender, and what we want to predict. And then feature scaling. Feature scaling is we scale all the data so that all features are on the same scale. This helps the model perform better. And then we go to this. What is this? Basically, this is to make the model learn or perform much better. That's all from me. I pass to the next presenter.
Hello, is Muhammad Amir bin Muhammad ZAIDI. Now let's take a look how we create a support vector machine or SVM model using Python and the scikit-learn library. So it's our coding here that you can see here. Okay, so the first we create the SVM model using the SVC, which stand for super vector classification. They come with the scikit-learn SVM module. Yeah, okay, so we specify the kernel type as a RBF, that as you can see here is called RBF here. So which stand for Ready Basic Function, and it is popular choice for non-linear data because it can handle more complex relationship between the feature. The comment here remind that we can experiment with other kernel type too, like linear, which is use the data is linear separable, or poly, which use a polynomial function for the separation. After creating the model, we train it using the fit function. We pass in our training data as train, which contain the input feature, and y train, which contain the target label. This step fit the model to our data so that it can learn the decision boundary needed, classify new ANSI sample. Once this training is complete, the model is ready to make a prediction. So here the prediction is just called SDC. See? So that's all for me. Thank you.
My name is Irfan bin Muhammad ZULKIFLI. So today I will present for the project Data Science Cmpd 383. So I want to explain about the step 6 is evaluate the model of the SVM model, right? So this the first to the make prediction. Okay, y is specific equal SVM model dot predict x test. Okay, this for the after the training SVM model using the train data. The next step is to use the model to make the prediction on the unseen data. In this case, the test we use to predict bracket function of the train SVM model. So and pass in X test, which contain the features value the model has not seen during training. Right. So the result the store in Y pre, which contain the model predicted output level. So the either 0 is not survive or the 1 is survive for the each passenger in the test of the set. Alright, so I move for the code for the print accuracy. Okay, this for the next will be calculate. The accuracy will be calculate the model comparing actual value, so the y test and the value for the y print. Alright, so we use the accuracy score to for the from the scikit-learn, which give the proportions of correct prediction. Alright, so the mathematically accuracy is calculate such accuracy equal number of correct prediction per total of prediction. Okay, for example, I give the model predict 17.5. Okay, this out of hundreds passenger. Okay, the accuracy is 0.75 or 75%. However, accuracy alone might not enough when the dataset is ambulance. For example, if most people did not survive, so a model could just predict 0 for everyone and still get the highest score. Right. So the next is for the print classification report. Okay, this is to be better for us understand the performance. We print the classification report. So using the classification space report bracket from student. Okay, this report will be important metric such as the first positions, second recall, the third F1 score, and the fourth is support. Okay, the prediction is all predicted positive. How many were actually positive? The second recall is all actual positive. How many did we correctly predict? And the third F1 score is the harmonic mean of pressure of recall which balance both. And the fourth is support. Support is the number of actual instant for each class. Okay, I give the example. Okay, prediction for class 1 is survive. Tell us how many people the model predicted to survive, to actually survive. And the recall for class 1, how many actual survivor were correctly predicted. Okay, this metric are especially useful when dealing with inverse data where one class is dominant. Right, so the next I move the confusion metric. Okay, confusion metric for the last. Okay, this is I want to print the last of the code is confusion metric. Okay, which is 2x2 the table used for to visualize the performance of classifications for the algorithm. Okay, the confusion metric show the following. The first is true positive to CP this correctly to predicted survivor. Kalau true negative correctly predict not survivor. Kalau false positive FP predicted survive but actually did not survive. And the last false negative FN is predicted did not survive but actually is survive. Okay, I give the output that I can be run this code. Okay, I look this. I for the accuracy is 0.8111 88811 So this is for the output. Okay, I want to explain this. Alright, so the accuracy, the model achieved accuracy is about 81.1% is which means out of the passenger in the test data set about 81% were correctly classified as either survive or not survive. Okay, accuracy is a good starting. The points evaluate the model, but it's not always enough, especially if the dataset is ambiguous. Okay, that's why we also look at precision, recall, and the coefficient metric. Alright, so the next is classification report. This you may look this. Okay, for classification report is 1, 2, 3, 4, and 5 column. This column is for the class, the second patient, third recall, F1 score, and the support. Alright, so the precision is for the class 0 is 0.80, which means that 18% of the patient are not survive, actually did not survive. For the class 1, 0.82, meaning 82% of the patient as survive, actually did survive. Alright, so I move the recall. This for the recall 8. For the class of 0, 0.88, or meaning clearly identify 18% for actual not survivor. However, the for class 1, 0.73 is mean correctly identify 73% actually survivor. Alright, so this indicate for the model is slightly better at identifying not survivor and survivor. Right, I move the F1 score. Okay, F1 score is harmonic mean of precision and recall. For class of 0, you look for 0.184, and for the class 1, 0.77. Okay, this value show how the balance the model prediction for the both of classes. Right. So the next is support. Support is refer the actual number of the sample for each class in the test data, there were 18 non-survivor and 16 survivor. Alright, so I moved for the macro AVG and white AVG. Okay, for the macro AVG ataupun for the macro AVG or the macro average. Right, so macro average, calculate the means of the metric, vision, recall and F1 score. This is for the both classes equally without considering class imbalance. Here the macro F1 score is 0.81, meaning the one average, the model performed quite well across the both classes. Right, so the next is weighted AVG or the weighted average. This is for the take class of support for the frequency into the account. Alright, so the since data set has slightly more non-survivor, and this metric often more realistic with the average F1 score, and also 0.81, which consistent and good. Alright, so I move for the coefficient metric. This right, so you look 17, 10, 17, 46. Right, this for line for class of 0, this for class of 1. Okay. Okay, for the coefficient metric, show the how tell the predicted is for the class. Okay, 17 is work correctly predicted are not survive, it's true negative. 10 if passenger were predict as survive but the call actually did not, so the false positive. Okay, the 17 is work predict not survive but they actually survive, it is false negative. And 46 were correctly predict survive, this is for the true positive. Alright, so this model is making slightly more very predictive survivor and the not survivor. Right, which line which record the score and we saw the earlier. Right, so the final summary for the steps here, I will summary this for the model. It's quite 81.1% for accuracy and balance prediction and recall. And for the clear coefficient metric shown reasonable prediction and slightly the identified actual survivor. For the overall, the FAHMI model is reliable and interval. Right, so I think that's all for me for the explanation for the step 6 at the predictor model. I will pass the next person to explain the optimal hyperparameter tuning, and that's all for me. Thank you.
Hello, my name is AS-SAIFI by MOHAMAD LIZAN. Now let's improve our support vector machine model by tuning its parameter using grid/CV. Grid/CV tries out different combination of parameter to find the best fit for our data. We specify a set of value for each parameter and it tests every combination with cross validation. For this model, I'm tuning 3 key parameter. So C control the penalty for misclassification with value 0.1, 1 and 10. Kernel, the type of decision boundary, testing radial basis function RBF, linear and polynomial. So for the gamma, which influence how far each training point effect reach, test, scale and auto. I set up grid search with 5-fold cross validation to make sure our evaluation is reliable and not biased by a particular data split. Here's the code run the grid search. When this finish running, it shows us the best parameter combination, the best average accuracy from cross validation. This process helps us pick the optimal setting so the model generalize better to unseen data. This project, first we grab the Titanic dataset and took a good look at the data. Then we clean it up by dropping column we did not need and got rid of any missing value. After that, we convert some of the text category into number, like turning male and female into 0 second and 1 second, and scale the feature so everything was on the same level. We then split the data into training and testing set, and training a support vector machine model to predict who survives. Once we had that initial model, we want to make it better, so we use grid stage CV to try different parameter combination like C, kernel type and gamma to find the best fit. And that tuning step actually improve our model accuracy, so it predicts survival more reliable. Overall, this process show how important it is to prepare your data well and tune your model's setting to get the best result. Thank you for today.